In this problem, we're working a very simple pressure force problem. It says, how large a force does the still air in a room exert on the inside of a window pane that is 40 centimeters by 80 centimeters? So, remind you that force is equal to the pressure, which would be the atmospheric pressure, times the area. Now, you can do this a couple of different ways. It depends on the units that you want to work. So, let's work first in SI. In SI, the pressure is 1.013 times 10 to the 5th newtons per meter squared. That's 1 atmosphere. We got to multiply that by 0.04 meters times 0.4 meters, not 0.04, 0.4 meters times 0.8 meters. And we do that with the calculator, and we'll find our thing. So let's see, 0.4 times 0.8 times 1.013 to the 5, and we get 32,416 newtons. So 3.24 times 10 to the 4th newtons, or 32.4 kilonewtons. All right. Now the problem is, of course, to know roughly what that is. Now, one way to do this is we could divide by 9.8, and that gives kilograms, and there's about 2.2 pounds of force is associated with 1 kilogram of mass. I'm going to do it instead with the SI units and look at it from that perspective. So this is solve the problem, but I want to look at our ability to work in units. If I do this in English, F is equal to 14.7 pounds per inch squared, PSI. In this case, we'll want to leave this as 40 centimeters and 80 centimeters, but there is, in 1 inch, 2.54 centimeters. And I want to square that. And if I look at that, I see that the centimeters and the centimeters are canceled by the centimeter squared, and the inch squared is canceled by the inch squared here. So I'll end up in pounds of force. Punch that into our calculator. 14.7 times 40 times 80 divided by 2.54 squared. And we get that it's approximately 7,291 pounds. That's a lot of force. Now, if there was just this force on one side, this window would shatter. The fact is that inside the house, there's an equal pressure that should be pushing in the opposite direction, and that's what keeps it from breaking. However, with a hurricane or something, the wind moves very fast, and if the wind moves fast, we're going to find from Bernoulli's equation that it can change the pressure on one side. If that pressure differential, so for instance the pressure is less on the outside, then the inside pressure, although it won't be fully the same force, will still be very large, and it can blow the window out. It can do more than blow the window out. It can literally blow the walls of the house off and drop the roof of the house on top of you. One of the things they tell you in tornadoes and such is to crack your windows, thereby allowing the air to go from one side to the other and equalize the pressure. All right, that takes care of this problem.